So today, this webinar is going to be an introduction into the Delacor queued message handler, working towards developing modular LabVIEW applications. My name is Chris Farmer from Wired In Software. As Mendel mentioned, we're an alliance partner. We're based in Melbourne, Australia. And I'm really pleased to have joining me today, Karina Taylor from Envisage. Welcome, Karina.
Thanks, Chris. I'm Karina. I also have my own company, Envisage, which is also an alliance partner of National Instruments, and I'm based out of Sydney. I'm really excited to be joining Chris today and giving you a quick intro into the Delacor queued message handler. We've had a bit of success with this toolkit over the past few projects where I've been working with Chris. So thanks for joining us today, and I'll be speaking to you later.
Absolutely. So let's get into it. So what is the Delacor queued message handler, or DQMH? We're going to refer to it throughout the webinar as. The DQMH is a tool for enhancing LabVIEW productivity. It is a development framework that leverages scripting to automatically generate LabVIEW modules. It is based on the NI queued message handler and producer-consumer design patterns. And it includes a built-in tester to help you test and debug your code as you write your application. It's also a free download via VI Package Manager. But what I'm going to do first, before we get stuck into the tools, I'm going to give you a bit of a background as to why you would want to even consider something like DQMH. So you might be wondering, doesn't LabVIEW already have enough tools to get the job done? Well, the answer is yes, it can, and in some circumstances. But I think just as importantly, the LabVIEW community, you know, they're playing a really important role in championing new approaches and new ideas. And just purely speaking from my own experience, we've found at Wired In that the DQMH best suited our needs at the time. So with regard to our agenda today, we're going to start by looking at what is good LabVIEW code. What makes a good LabVIEW architecture? We're going to follow this up with a short and brief journey into a typical LabVIEW development evolution. Then we'll step into introducing the DQMH. What is it for, and why would you use it? And Karina's going to give us a demonstration on building a very simple DQMH application to get us up and running. Finally, we're going to talk very briefly about an example project that Wired In we're right in the middle of developing, and we're using DQMH as our primary framework. So let's get into it. So let's talk about good LabVIEW code. So what is good LabVIEW code? So for me, good LabVIEW code, there's a few things that come to mind. First of all, good LabVIEW code is modular. A modular architecture allows for expansion. It allows multiple developers to easily work together, and it increases reusability. Modular code allows you to extend functionality without changing your existing code. Create a new module rather than hacking into existing VIs. So this limits the risk of breaking existing code, and therefore the need to retest your code. The code that you only need to test the code that changed. For me, good LabVIEW code uses common design patterns. So a design pattern can be seen as a proven method for tackling a programming challenge. It has the added benefit of a sense of familiarity between one developer and the next because it's common. Good LabVIEW code is typically found and built in to a robust framework. A framework being a collection of tools that help build modular applications. Often the tools provide a convenient messaging platform to allow modules to talk to each other. And the framework tool is usually something that's going to improve your productivity. And finally, I think good LabVIEW code is easy to test. How can we test our code? You know, we want to be thinking about this during the design phase. This is an often overlooked aspect of writing good LabVIEW code. So let's get started. So modules. So right at this point, I'm going to open it up here to our audience. I want to see if we're going to get any feedback here. We've got a few participants. I'd like to see if anyone can tell me what does a module mean to you? What is modular code? Can anyone share some light on that? Okay, well, I'll keep moving. Oh, we've got someone typing. This is excellent. For me, modular code is code that's independent from other code. We've got reusable from one listener. That's exactly right. I think also modular code is specific in function. So you write a code module to do one thing. You write a driver to communicate to your oscilloscope, and that code does nothing else but that. And we've also got another comment, a code that is reusable without major changes. Absolutely. Good feedback, thank you. Keep them coming. What form does a module take place in LabVIEW? Well, commonly you might see LabVIEW library or LabVIEW class. Another comment from the audience, it's a LabVIEW module is flexible. These are absolutely correct. So that's a module. The next one I want to talk about is design patterns. Once again, can anyone shed some light on what we mean when we say design pattern? Well, while the comments are coming in, I'm going to keep things moving. But for me, a design pattern is a common and proven way to code. For instance, you might be using something like a queued message handler. A queued message handler is an existing template that ships with LabVIEW. If you open up the queued message handler template, it's got that all familiar producer-consumer type of pattern where it's two while loops in a single VI, and one's handling events, the other one's handling the messages that extend from that. So a common way of going about it. The third thing we mentioned before about good LabVIEW code, frameworks. Okay, can anyone tell me what does a framework mean to them? What do we mean when we say framework? What frameworks do you use, even if you want to throw any up there? We've got a few comments coming our way. While we wait for a few of those to come in, we can think about some frameworks that might be familiar to us. We're looking at things like the Active Framework, which comes delivered with National Instruments LabVIEW. Or if you're a real-time developer working on a compact Rio, you may have heard of one called DCAF. That stands for Distributed Control and Automation Framework. So what might you expect from a framework? For me, I think a framework is going to have a bit of automation built into it. And another good point is the help and support and examples are really important aspects of a framework. So it might be a good point to just clarify what's the difference here between a design pattern and a framework. So the way I like to think of it, a design pattern is like a template for one module. It's typically a single module or a single VI architecture. It's just a way of approaching a challenge or a task. But it's kind of limited to one group of VIs. To go a little bit further, a framework for me is allowing for expansion to have multiple modules being developed and interacting. Also, a framework is going to provide an inbuilt mechanism for how the modules communicate with each other. I think that's really important. So our fourth point, back earlier we were talking about what's good LabVIEW code. My fourth point was testing. And testing is an often overlooked aspect of when we develop LabVIEW, because it's so productive, we just get in there and we don't think about testing our code all that well. So, but what are some considerations we might like to think about when we're writing good code and when it comes to testing? Well, my first thought is by making our code modular, we'll have an easier time of testing. Not only that, if we design for tests, if we think about tests a little early on during our design of our application, well, you know, the benefits are going to start to roll out. And one of those might be that when we want to change or we need to make new changes to a module, it's unlikely to affect other modules. So testing is retesting that module is isolated to that module. It's a really important point, that one. So testing is just as important. How do you test your code? Write your code so that you can test it. All right, so we've talked about good LabVIEW code, and you might be wondering at the moment, why? Why are we even bothering? Why do we even need frameworks or design patterns? What's this all about? Where's this going? So bear with me. We're going to look at a typical LabVIEW journey right now. We're going to pack down 20 years of LabVIEW development experience down into a couple of minutes, and we're going to focus on 3 main steps of a LabVIEW evolution. You write your first LabVIEW app, you then have to put it out in the production world, and then the whole enterprise wants a piece of it. Let's go. So let's start with your first app. Your boss says, hey, you know, let's use LabVIEW to run some verification tests of our new product that PD is designing. I hear you can connect it up to the scope, and we could automate that measurement real quick. So you're up for the challenge. Your boss has put it out there. We open up LabVIEW, we start cobbling something together, and it's not bad. LabVIEW's rapid. We're easily developing something. We can acquire data from an instrument. We can present that data really nicely on some pretty graphs. We're going to export that data to Excel for further analysis. We're getting real productive here. It's happening and it's doing the job. LabVIEW's the hero. So that's awesome. Stage 1 done. A few months later, your boss is now saying, okay, production can't keep up with their manual testing due to high demands. How about we grab that software you wrote and put it at the end of the production line? Okay, challenge number 2. So all of a sudden you're thinking, right, we're going to take our little tool we wrote for our lab earlier and we're going to put this on the production line. Hang on, there's a few new requirements now. There's a few more things to do and consider. For instance, our GUI, we just sort of whacked something together. It looked nice with a couple of graphs, but we've got to keep it simple. We've got to keep it simple for the users, clean and easy to use. Other things we need to think about is this thing's got to be reliable. Other people are going to use this now. You know, it's got to handle errors well. It's got to be robust. People are depending on us. Okay, new features. All of a sudden, we've got to do user logins. We've got to write more detailed reports. We've got to do calibration of our instrumentation. It's getting more involved. We've got to run it as an executable. No longer have we got the comfort of our development environment. We've got to let it run on its own 2 feet. And we need to prove this thing's going to work. We've got to make sure that when we say pass, it's actually a pass, or fail equals fail. So what's our solution? Our solution is starting to look a little bit more involved. It's getting fairly detailed now. We've got a single main.vi. It's got a lot of loops, which we used, you know, in our original app. The block diagram's growing. We got local and global variables. We got lots of wires. Yeah. The front panel, it's getting busy too. Lots of controls and indicators. The workflow for the user, it's a little unclear. And yeah, if you look at the files on disk, it's just a flat file structure. We've got sub-VIs everywhere. We don't know how they all fit together, but they do. You know, I'm wondering if this is sounding familiar to anyone. You know, it's a mess. To be brutally honest, it's a bit of a mess now, but it works. It works for now, and production's underway, so things are great. We're rocking. So then a few months later, the bar's been set high. Your boss says again, "We're so impressed with this LabVIEW, I can see we can use it in other departments. Can we get the production department with a new tester by the end of the month?" Expansion considerations. All of a sudden, we've got to think about these things that, you know, we're thinking about new products. We're thinking about new instruments. We're looking at having to do new tests and analysis. We've got to deal with different IT infrastructure. We've got to potentially deploy this thing to new countries. So what do we do? How do we, you know, we're now expanding to the whole organization here. How do we reuse our code? Well, the honest answer is it's really hard to reuse this code now. It's labor intensive to update and maintain. We're finding it hard to add new features. We're finding it difficult to test, change one thing and break another. We're difficult to share the work with other developers, and if we get another developer to have a look at it, it's really hard to follow because we kind of slapped it together as we went. So, end of the day, LabVIEW is not looking like the hero anymore. You know, everyone's looking at you for advice here, but you know, things are coming along a bit slow. So what I'm trying to do here is I'm trying to paint a picture. I'm trying to paint a picture of you know, writing a real simple LabVIEW programs early. It was easy. We didn't think about design or good coding too much. We just put something together, and you know, we've now progressed. It's being used everywhere. But it's hard to maintain. It's hard to look after it. So what do we do? You know, potentially what we've got to do at this point is we've actually got to ditch or scrap our current system and almost start again. And no one wants to hear that. So what do? We hear about frameworks. We consider a framework. So we look around on National Instruments, and there's some really good ones out there. We've got Active Framework, we've got Goop Development Suite. These are NI-supported frameworks. They're very powerful. I know a lot of people that swear by these frameworks, and they are extremely productive and well supported. So recommend looking at those if you're interested. But you know, they're for advanced users. There's a fairly steep learning curve. So what if your team isn't, you know, up for advanced yet? If you're still learning object-oriented programming in LabVIEW, these tools are going to be quite involved. So you've got to take it one step at a time. Is there anything else? Well, yes, that's when Wired discovered there's this thing called Delacor queued message handler. So I just want to point out that there are some alternatives out there. So this is just one that Wired's used, and we've used it to great effect, and we're really pleased with it. But if you want to learn more, jump on the NI website and search for Reference Design Portal, and there's a heap of content there, and other people are putting up their own frameworks, and certain frameworks suited to to certain applications. So this is just one that we use and we like to use. So I just want to recap. I've just given you the typical LabVIEW journey. I'm wondering whether it sounds familiar to a few of you. It's kind of similar to what I experienced over a 20-year period, and we've now selected the Delacor queued message handler. We use it in-house for a number of projects, and so we're now going to focus in on the Delacor queued message handler. What is it and why we're using it? So I want to just highlight a few of the features of it and the benefits that come from that feature. First of all, it's based on the National Instruments queued message handler template. And so for those of you who know that, then there's that instant familiarity because it's using LabVIEW design patterns that are well received in the community of LabVIEW developers. Secondly, it's using an event-based messaging mechanism, which is really a great way to communicate between modules. And not only that, it's encouraging common practices, common programming from one project to the next or one developer to the next. The tool itself uses a lot of VI scripting to automate the tasks. It results in fast and easy creation of our modules and our events. We think DQMH is ideal for multi-module applications, and it can easily handle multiple developers for this reason. So you can have one developer writing a system configuration module and another developer writing a test module and another developer writing a calibration module, and that is not too far from a scenario where Wired-In is working on a project as we speak. The other thing is it's leveraging a lot of object-oriented programming under the hood. And the big benefit here is that if you've got a module that you need to make multiple instances of, well, the object-oriented capability makes that really easy. And not only that, does the object-oriented, it's kind of hidden away. So if you're a bit worried about object-oriented, don't worry. It's using it, but it's not there in your face. So it's a gentle introduction, shall we say. The other thing is it's downloadable from the NI Tools Network. The benefit being that it's free and it's got great comprehensive help and the support is top-notch. And it might be a good point to say welcome to Fabiola. I see that she's in the participants today. Fabiola works for Delacor and we work together on a few projects using the DQMH. So welcome, Fabiola. Continuing on, the final feature I want to point out, the tester VI, it's underrated. Every module that you create, it automatically creates for you a tester VI, and its built-in debugging capability is second to none because you can watch or sniff your program as you run it and debug things as it's running. And it's like a window into what's happening. It's really powerful. Not only that, you can use it to test your modules in isolation, which is also a very powerful feature. And it's a pretty popular download, and that kind of speaks for itself. So that's DQMH and why we've considered it. And you can easily just go to the VI package manager and type in Delacor, and you'll see there on my image that you can download Delacor QMH. If you're wondering, version 4 is not released. That's a beta version we're trialing, but it's currently version 3. And just install Delacor to the LabVIEW version of your choice, and and you can get started. So at this point, I'm going to hand you over to Karina, and we're going to dig a little bit further into what the terminology of DQMH has, and then she's going to give us an introduction on how to actually use it, and we're going to get on the tools. So over to you, Karina.
Thank you, Chris. So we're going to jump right in and learn the absolute fundamentals of DQMH, basically so that you can get stuck in and start using it. That is the aim for me, for you to be able to do that at the end of this seminar. So let's look at the two main things that there are in the DQMH toolkit. The first is a DQMH module. A module is basically a code thread that is implemented using a queued message handler design pattern in LabVIEW. This is really fantastic because a lot of people are fairly familiar with the queued message handler design pattern already, or if you're not haven't seen that before, you've probably seen the producer-consumer with events type design pattern. If you're familiar with those, you can pretty much jump in and start using DQMH right away. It'll make sense to you. DQMH modules can be one of two types. The first is a singleton, which means that that DQMH module can only have one instance of its main VI running at any one time. A module could also be clonable, which means that it can have one or multiple instances of its main VI running. And we'll see in our demo or system design that this can be a really useful feature. The next major thing within the DQMH toolkit that I want to teach you about is a DQMH event. This is a method of sending messages between modules, and it's implemented with user events in LabVIEW. User events for the intermediate level programmer can get a little bit tricky, but the awesome thing with the DQMH toolkit is that all of this event code is scripted, so it's automatically generated for us, so we don't even have to go in there and figure it out ourselves. We can modify it if we want to, it's all there to modify, but we don't have to really know about it to get started. There are two main types of DQMH events, and the first is a request event. A request event asks the owning module to do something. So when we start with DQMH, we first start by creating a new module, and then we can add events to that module, and those events can be request events or broadcast events or other types of events. So a request event asks the owning module to do something. It creates a VI in your project that you can use in any other module that will trigger the module that the event lives in to run some code. It triggers an event in the producer, and that can generate a message that goes down to the consumer if you wish, and it can run some code in the consumer. It is a many-to-one message mechanism. Also, before I talk about broadcast events, request events can be expanded slightly. We can have a request event that then replies to the sender of the event with a payload of data, or we can have a request event which replies with a broadcast event. So we can have combos. So a broadcast event is the second type of event, and it fires an event from the owning module to anyone who is listening. And this is a really important concept, that request events are kind of incoming and broadcast events are outgoing. Other modules can register to receive and handle broadcast events. So it is a one-to-many communication mechanism. So let's now look at a case study. We're just going to come up with an example set of requirements that we're going to use to demonstrate how DQMH works in a real application. So let's say we have been asked to build a temperature monitoring system, and for the purpose of this demo, we're going to keep it pretty simple. So let's say we've been asked to be able to launch any number of temperature monitors based on the user's needs. Each of these temperature monitors will have its own user interface, and it will be able to do its own limit checking and individual limit control. So you can see an example front panel on the right there. Because we are going to launch multiple temperature modules, we're going to need some kind of a launcher VI. So this VI is going to launch and manage all of the temperature modules that we need in any instance of our application. It will have a button on it to add temperature modules as we need them. Now this launcher might turn into our main user interface as this project becomes larger and more complicated and more featureful, but at the moment we're just using it as a simple launcher. Let's say that we've also been asked to create a configuration screen. So this screen allows us to globally change the limits on every open instance of the temperature module. So instead of having to change every low limit to 25 and every high limit to 65, we can do that from the configuration module. Let's say we also need to be able to add temperature modules from the configuration screen as well as from the launcher. Now, we don't want to go and write the code to launch temperature modules from the configuration screen again, the same as we did from the launcher, because in the future, if we have to modify that or update it, we don't want to have to do that in two places. So rather, we're going to have all of the launching code in the launcher module, and we're going to call that functionality from the configuration module when we hit the Add Temp button there. So let's see how we could design this using DQMH. It's pretty clear where our modules lie. Our first module is going to be the launcher module. It's going to be a singleton because there's only ever going to be one of them. And it's going to have a single event called add or add temp. We're going to make that a request event because we want other modules, i.e. the configuration module, to be able to request for the launcher to run the add temp code. Our next module is going to be the configuration module. Again, it's a singleton because there's only one of them. It will have its own limits event. And this is not going to be a request event, it's going to be a broadcast event because we want to broadcast the new limits or the global limits to any open temperature module. Finally, we have our temperature module. It's going to be clonable because we need any number of them to be open. The temperature module doesn't have any events of its own. However, it will subscribe to the configuration module's limits event so that it can update its internal limits anytime the limits are changed in the configuration screen. Hopefully that makes sense to everyone. Feel free to write down some questions and Chris or I will try to answer them as we go along. But basically what we're going to do here is jump in and see how this would be developed completely from scratch in about 15 minutes using the DQMH toolkit. So I'm going to jump over to a video here. Basically, my development environment that I have here is just LabVIEW 2017, the latest DQMH toolkit that I downloaded from the iPackage Manager, and the OpenG toolkit, so nothing out of the ordinary. I have pre-recorded this demo just so I can concentrate on explaining the concepts and what I'm doing rather than concentrating on what I'm doing. So hopefully this will give you a better overview of how it all works. So we're starting with a blank project and we're just going to save it as DQMH. So the first thing, well, let's just see how when we install the Delacor queued message handler, we have a new menu system under the Tools menu. So we have under Tools, we have Delacor, DQMH, and we have a number of options that we could do there. We've got Add New DQMH Module, Add New DQMH Event. These two we're going to be using throughout the demo today. We can remove events, rename modules, and we can validate modules if we're moving between versions of the DQMH toolkit. I'm just going to quickly jump back to the presentation slides as a reminder and show you that we're going to first start with the configuration module. So what we need to build here is a singleton configuration module with a broadcast limits event. Let's do it. So we're going to add a new DQMH module. So we get a little dialog box here. We can write the module name. We can choose whether it's a singleton or clonable, and in this case it'll be a singleton. And then we can create a nice header for our icons for all of the VIs that are going to be created in our module. We press OK, and you can see that the DQMH toolkit goes off and generates a whole stack of code. That module will work on its own. There's no code that is needed to be written at this point for that module to work. It's a fully functional piece of code and it can be tested with a test API. So we can go straight in and create our new DQMH event. We're going to create a broadcast event. We're going to call the event limits. We're going to enter a reasonable description for the limits event. And over on the right in the arguments window, we can define the data that will be sent in the event message. So in this case, we're going to send our new low and high limits, just using numeric controls. We press OK, and the DQMH toolkit will go off and script most of our event code for us. What happens now is that the VIs that we need to complete to code up our event have been opened for us so that we just know where to put our new code. The first VI that opens, or the top VI that opens, is the tester. So as Chris mentioned earlier, every new module, or every module that you create in the DQMH toolkit, has a corresponding tester. And that tester simply allows us to test every event that is created for that module. So we can run that module on its own from the tester. We can jump into the block diagram from the tester. We can show its front panel, its block diagram. We can open it and close it and see all the status updates that are going on in that module at the same time from the tester. So the first thing that we should always do when we create a new event is add some code to the tester so that we're able to test that event in the module. So as we can see in the block diagram of this tester, already the tester is registered to receive broadcast events from the module that this tester belongs to. So the event structure here is listening to the config broadcast events limit value change user event. So we're just going to pop some code in there to display the new low and high limits from our broadcast event on the front panel of the tester. And you can see in the data node within that event structure, we can get the low and the high data from that, and we can do whatever we want with it. In this case, we just want to display it in the tester. And as Fab is saying in the chat pod, please, please, please use your testers and update it every time you add a new event. Otherwise, you'll find it yet less than useful in the future. And I can tell you from experience, they are really, really useful. So once we've updated our tester, we now are presented with the code for the main VI of our config module. So what we're going to do is pop our global limit variables on the front panel. We're going to create a value change event for those. So whenever the low or the high limit value changes on the front panel of the config module, we're going to take this really handy VI that was put here for us with a nice big blue note or label to say drop this VI wherever you need to broadcast the limits message. So whenever we use this VI, that message will be broadcast to any other modules that are listening. So we're just going to pop that in the value change event, delete the label, wire in the low and high limits, and our code is done. All of the messaging in the background was pre-written for us when we created the event. I'm just going to take a moment to show you the folder structure for a module in the DQMH toolkit. So basically we can see that we have a config module folder, a config LabVIEW library. Within that we've got a main VI down the bottom of that library, and the tester sits outside of the library because it's testing the whole module. It's not kind of part of the module. Within that library we have a bunch of private folders broadcast, requests, private, blah, blah, blah. Inside those are a whole stack of sub-VIs that are required for that main VI to do its thing. They're just all the background VIs. You can go and look at them if you want, but generally we can just ignore them. The important part of the config module is the public API library. And this is what we use from other modules to call all of the events within this module. So we can see when we create a new module, we already have a show panel, hide panel, stop module, get module execution status, and show diagram. These are all request events that can be called from outside of our module, for example, from the tester, which they're already been used in. We also have some pretty critical VIs: start module, synchronize module events, and obtain broadcast events for registration. Start module is pretty self-explanatory. It starts a module. Synchronize module events we need to use after the start module VI just to make sure that all our events are ready to go. There's no point sending messages to a module if it's not ready to receive them. Our obtain broadcast events for registration VI is what we can use in any other module to register to listen for broadcasts. So if you can remember the design, our temperature modules will be listening to the global limit updates from the config module. So the temperature module will be using that obtain broadcast events for registration VI from the config module. Let's now have a quick look at the main VI of our config module. So as we can see, it is a queued message handler architecture. It has the event structure at the top and a state machine down the bottom. And what we're seeing here is the show panel request event that was automatically generated with this module. So every time another module or another VI calls the show panel request event VI from this module, the event structure up the top, the show panel case will be triggered, and that will call the show panel case down in the consumer loop, and it will do its thing. So it's not that hard to follow if you're familiar with the queued message handler already. We're now just going to have a quick look at how we could use the tester to run and test our new module. So we can start the module from our tester, we can show its panel, we can hide its panel, we can show its block diagram for troubleshooting. This doesn't seem so awesome when it's just a single module running in isolation, but if your module is clonable, or if your module is running in the sub-panel of another VI, it's often very difficult to open the relevant block diagram for troubleshooting. You could just open this test config API and open the correct block diagram. It's really, really handy to be able to debug. Let's also check that our broadcast event is working. So if we change the low limits in our config module main VI, the corresponding limits on the tester are updating because they are registered to listen to that broadcast event. So it looks like our config module is working. Before we go ahead and build our next module, let's just have a quick review of the design. So the next module that we're going to create is the temperature module. So we can see that that needs to be clonable. It doesn't have any events, but it does need to subscribe to the limits broadcast event from the config module. So we're going to create a new DQMH module. We're going to call it temp. We're going to choose it to be a clonable module, and we're going to give it a nice icon overlay.
Karina, this is Chris. The video is restarting, so you need to skip it ahead to 6 minutes or whatever it was. Yeah. So maybe not jump back to the presentation,
slides,
unfortunately.
So we'll create a new DQMH module, and we're going to create the temperature module. It's going to be a clonable module. And we create a header. So you can see in the background the temperature module code being developed. And we don't need any events for this temperature module. But we need a front panel and a block diagram that basically simulates a temperature being generated and displayed and is able to change limits for that temperature. So we're going to have a chart here with a simulated temperature. On the front panel, we're going to create a high and low limit numeric control. And finally, an overlimit indicator. Now, you've all probably seen this sort of code being written 1,000 times. It's a good kind of hello world type code for LabVIEW. So in the block diagram, we're just going to put the simulated temperature code in the timeout case of the event structure. So we create a new event case, allocate it as the timeout event case, set it to run every 500 milliseconds. Just going to use the OpenG function, random number between two places. We're going to create a random number between 20 and 70. Then use the native LabVIEW in-range and coerce function to check whether our random or simulated temperature is between our high and low limits. The output of that will tell us whether it's within the limits. So we will not the output of the in-range and coerce and send that to our overlimit indicator. And finally, we will attach our random number to our simulated temperature chart so we can see the history of our temperature. So that's our code for our temperature module. Obviously, in the future, we could hook that up to some actual temperature reading device. But what we need to do now is register to receive the limits event from the config module. So we go into the config module in the project and we grab its obtain broadcast events for registration. We wire that to the DQMH register for events node in the Cube message handler. And magically, we can access all of the broadcast events from the config module now, including our limits event that we created earlier. So in that event case, all we're going to do is grab the new and high limit from the config module and overwrite our user interface values using a local variable. And that is our temperature module completed. Finally, if you remember the design, and I'm not going to jump back there in the slides, we need to create one more module, the launcher module. It has a request event called add temp. It's a singleton. So we're going ahead here and adding a new DQMH module. Calling it launcher, giving it a nice label or overlay. And we're going to create a new DQMH event for the launcher module. It's going to be a request event this time, and we can select the module that it belongs to because there's more than one now. And we're going to call this event add temp. This event doesn't really need an argument, but I'm going to leave the Boolean there just as a placeholder so it's easy enough to expand my event to do more stuff later if I want to. Okay, so we've opened the tester and we just need to be able to add some code to test our new event in the launcher. So we're creating an add button, adding an event case that is just a value change for that add button, and we're going to wire that in to the add temp request VI for the launcher module. And you can see there's a nice label there telling us what to do. So this will trigger the add temp request event in the launcher. We've closed the tester now and we're inside the main VI of the launcher module, and you can see that it has the request event incoming through the producer up at the top there, and then that will send a message down to the consumer state machine to add temp. So we need to add code in the consumer there to launch a new instance of the temperature module. So to do that, we can just use the VIs from the public API folder in the temperature module. So we're going to start the module. Synchronize module events, and then open the front panel of the temperature module. So every time add is pressed, this code will run. And because it's a clonable module, the temperature module, it has a module ID input and output from those start module VIs and show panels, etc. So we're just wiring that through. So whichever module we started, we're also going to synchronize module events and show its front panel. The launcher VI requires an add button as well, so we can respond to incoming requests from other modules, or we can do exactly the same code using an add button on the front panel. And to do that, we can just duplicate the code from the request event in the producer and allocate that to a value change on the add button. So it will just call the consumer code down the bottom. So now we can call that add temp code from either the UI or from another module. The other thing that our launcher needs to do is to launch the configuration module. So in the initialize case of the state machine down the bottom, we're going to use the start module, synchronize module events, and show panel for the config module. And in the exit case of the launcher, if we close the launcher, we want all of the other open modules to exit as well. So we're going to call stop module for the config and any open temperature modules. Because temperature module is clonable, we have to wire in a -1 to the module ID, and that will close all currently running instances of the temperature module. So that should be our launcher complete. Now there was one last thing that we needed to do. We needed to be able to call that launcher add temp event from our config module. So remember, the requirements asked us to put an add button on our config module as well. So we're going to pop that on the front panel, create a new value change event for it, and simply call the add temp request event of the launcher in that value change event case. And there we have it. That code should be fully functional now. So what we do is we run the launcher. It should run the config because we started the config and showed its front panel in the initialize case. We should be able to add temperature instances from either the config screen or the launcher screen using the launcher's add temp request event. We should be able to individually change the limits of individual temperature module instances. And we will finally test that the config module can globally update limits using the limits broadcast event. So if we change the low limit from the config module to 25, all temperature modules should respond and update their limits accordingly. And similarly with the high limit, if we change that in config, it'll change all temperature modules. Finally, if we close the launcher, it should exit the config module as well as the temperature module. So there we have it. Hopefully You now have enough knowledge to install DQMH and get coding. I'll hand you back over to Chris.
Thanks, Karina. That was really good. So there you have DQMH. So the final thing, we're running short on time here. I wanted to introduce you to an example project where we're actually applying DQMH at Wired-In software, and this front panel has been taken from a project we're currently working on. So the things I want to highlight is that in this highlighted section here, what you're actually seeing here is a subpanel. Now, we use subpanels quite a bit at Wired-In. It's a great way to be able to control what the user looks at. And what we've done is we've placed in here a DQMH module's front panel, right? So that is what you see there is the front panel of one of the DQMH modules. If I click on any of these buttons up here, it will change what I want to see in the subpanel, and it'll actually show a different front panel of a DQMH module. So what's happening in the background, we've got a whole host of DQMH modules. We've got one for calibration, we've got one for system configuration, we've got one for manual editing, and we've got one for user management. All of these modules, they're all running in the background, but we're only looking at one at any given time. Now, the other important thing about this particular application is that you have embedded inside this particular panel 8 more subpanels. And what we're putting inside those 8 subpanels is what we're calling a test channel module, and that test channel module is clonable, so we're calling that 8 times. So you can see that the code from 1 to 2 to 3 to 4, the front panel is exactly the same. The beauty of this is we wrote the code for one channel, we can duplicate it 8 times, and we have this thing running 8 times, and they're all independent of each other. So this allows us to test, in this particular example, to be able to test more than 8 or up to 8 products at any given time. So that just gives you hopefully puts it together about how we've actually been able to use the DQMH to great effect. Unfortunately, we don't have enough time, but you could spend another hour showing you underneath the hood of how this project works. So in conclusion, LabVIEW is now the hero once again. We got a little lost there at one point, and now we're back on track because we've now embraced a framework that is offering a number of benefits to us. So our advice out of all this is that use a framework to improve your development. It'll promote a common development style amongst your team. So therefore great for teams and productivity gains. And your code's going to be able to grow and change a little easier. It'll be less going back to the drawing board and more just adding and removing features where required. The DQMH is quick to learn and great for young developing teams and even advanced developers. I mean, you know, Karina and I are both certified LabVIEW architects, and we love DQMH because it just seems to kick a lot of the goals that we need. If you're interested, there are some links here for further info, but I'm pretty sure if you type in a DQMH into Google, you're going to get plenty of hits, and there's a lot of good information out there. So that wraps about everything up. Thank you very much for being here with us today and letting us tell you about how we go about things and how we've embraced DQMH as a framework at Wired-In and at Envisage. Thank you, Karina, for doing this with me.
Thanks, Chris. Thanks to NI for giving us the opportunity. And thanks to Fabiola for being in our audience and giving us shaky knees. No, and thanks for the tips. It's been awesome using the DQMH toolkit, and we're really happy to be showing people how to use it.